So our significant ideas is that water pollution, either groundwater or surface water, is a major global problem affecting human and other biological systems. You should be able to name some pollutants, identify where they come from, their entry points, outline how they move through the systems, describe their impacts, and then summarize and justify different strategies to deal with them. There's a few different types of pollution sources. A lot of these are actually nutrients, which is kind of funny to think about nutrients as pollution. But really, pollution is just the amount of substance that's too much for the environment to handle. So even if you could have too much of a good thing, right? Here we have too much of a good thing. And you can see the source of this nutrient. A lot of it comes from crops or maybe from livestock from their waste. And then also from some urban sources too. So there's a variety of pollutants here. A lot of times they're sort of utilizing the water cycle to end up in bodies of water. So maybe you're spraying some pesticides on your lawn and then it rains and then it all flows into the lawn. Or maybe you have some cesspools for your animals and then there's a big thunderstorm and they overflow. So here's some examples of pollutants. We got debris. Of course, we're always trying to not use single-use plastic, but any single-use item is not very good. You just used it one time. We could have nutrients, especially nitrates and phosphates, as a pollutant. We could have some solids. So here you can see turbidity, the amount of suspended solids in water. And depending on your ecosystem, this could be natural or unnatural. In the desert, I mean, sediment's pretty normal in the rainy monsoon seasons. In a place like Alabama, usually your streams would flow pretty clear because the water is being filtered out by all these plants. Notice how we don't have a lot of plants, so the water picks up more dirt here. Hot water, actually, thermal pollution is a big problem too. You can see the temperature anomalies here. And actually, this is all hot water, right? In the Southwest, we have the opposite problem where the water is too cold for a lot of our native fish species. They're used to the warm, deserty waters, and then we built a bunch of dams, and the chubs are having a bad time. Or it could be an invasive species all over aquatic systems as well. So we could test these with different parameters. We could measure pH, we could measure temperature, we could look at turbidity. There's some cool methods to do that. Or you could also measure the amount of nutrients in there. And looking at biochemical oxygen demand is actually one way of measuring how much nutrients, how much decomposable material is in the water. So biodegradation uses oxygen as we're composting material. All those composting organisms are respiring. They're using oxygen. And eventually that could lead to anoxic conditions where you don't have enough oxygen. Let's see the example here. And so biochemical oxygen demand is the amount of oxygen that you need to decompose all of that material. So after lunch, we always add extra food to the compost pile, and now there's extra food for the critters to decompose there. So they're going to have to use more oxygen to decompose the extra amount of food, right? And so more respiration requires more oxygen. And so the demand for oxygen is what causes the supply to drop. As there's an increase in biochemical oxygen demand, the actual amount of dissolved oxygen decreases. Just like when there's a demand for chicken nuggets, the supply of chicken nuggets decreases dramatically. Another way to tell about polluted waters is indicator species. We went and did this in the creek when we were looking for all the fun little crawdads and stuff like that. And you can actually use a biotic index to calculate sort of a value level for how clean your stream is. You don't have to memorize this formula. You probably just have to memorize the formula for like NPP and GPP and R. I've always seen them give you formulas for things like Simpson Diversity Index, for things like Lincoln Index, for things like Biotic Index. But you should know how to use them, and you should know that the Biotic Index tells you how clean a stream is based on which critters you found there. Indicator species. Okay, eutrophication. This happens in bodies of water, either lakes, estuaries, or coastal systems that get a big influx of nutrients. And I guess you could have it out on the open ocean too. So basically this process, you get an input of excess nutrients, usually from fertilizers, or maybe from like sewage is another big one. And all these nutrients make the algae go crazy. They're like, yay, we get a ton of food to eat, let's reproduce. And then they spread like mad, as you can see here, creating a bloom or a mat. And this causes a lot of crazy effects, right? So there's some more food for decomposers, but then there's also plants not getting sunlight. There's a lot of complicated effects with the food chain. But eventually, the algae will use all of the nutrients, the algae will die, and then the decomposers are going to be consuming, right? They're going to be digesting all of that algae. They're going to be respiring. They're going to be using oxygen, so their demand increases and the amount of oxygen decreases. And in really bad situations, maybe they're actually going to use pretty much all of the oxygen, and you can get to hypoxic or completely anoxic areas where there's low or no dissolved oxygen at all. Let's see. So here we see some people with fishing nets removing algae. So this is one way to physically to clean up a system. As you can see, pretty labor intensive. And then dead zones happen when there's not enough oxygen. A lot of times this is directly connected to eutrophication, though you could have some natural and pretty like irregular instances of this. Generally, there's a lot of mixing in the ocean, though you could get a lot of rivers here where you might have fresh water coming in and that traps the water underneath, and that water underneath might be a little bit lower in oxygen levels. But the really dramatic stuff is mostly human caused, and that's mostly from all of our farms pumping in tons of eutrophication, tons of nitrogen and phosphorus and everything. So hopefully you can identify the connection between the amount of oxygen here and the eutrophication process. And maybe if you look at the river systems here, maybe that would make a lot of connections as to why they're over here. And then as you get further from land, it's a little bit better. And then you also should do some pollution management strategies. So remember, we have 3 levels. We can reduce the activity. So here the activity is whatever's creating too much nitrogen, whatever's creating too much phosphorus. Maybe that means you're using less fertilizers. Maybe that means you're going organic. Maybe that means you're using your fertilizers at different times. If you use your fertilizer right before a rainstorm, you're not only going to pollute the water, but you're just going to lose all of your fertilizer to the river. So we could reduce it at the release too. So you could treat wastewater as it's coming out of the system. And then release it afterwards. This is what they do at places like Sweetwater in Tucson, and actually Sedona Wetlands does this too. Or we could take the pollutants out of the environment after the fact, the last stage, cleanup and restoration. So that was when we saw them with the big nets. This might be involving reintroducing some species. Maybe you lost all your fish and you have to put them back in there. You might remove some mud. It's called dredging. They scrape the bottoms. So some skills, you should be able to analyze some water pollution data. You might ask which country has the highest level of pollution here, which one is experiencing lower levels of pollution. Here you might look at the trends through time, and it looks like agriculture has actually been decreasing through time, whereas other industries are increasing. I wonder what is included in this other one. If you were curious, you could actually find that link here. Cool. And anytime you have an analyzed question like this, it'll actually give you the graph. And then hopefully you can explain the process of eutrophication. We add some nutrients. They run off either underground or above ground in surface runoff. And then that causes algae to grow because they have the limiting factor. And then that blocks the sunlight, which affects all the plants down here. And then at some point they have 6 and 7. I don't know where 6 and 7 are on here. Probably they're talking about complex interactions with the food web, and then the algae will die, and then that will be decomposed, and as it's being decomposed, all of the decomposers are using up the oxygen, and that's not leaving any for the fish, and they are dead. You should be able to evaluate positives and negatives of indicator and biotic indices. So what are strengths of this system? How could it be better? And then evaluating pollution management strategies in general. There should be specific examples in the textbook too for dealing with eutrophication specifically. All right, as always, shout out to Mr. Kramer for his great website.